Hello, it's time for decomposition reactions. All right, be sure to read through the background information and procedures so you know what's going on. And we're gonna do a quick walkthrough of this lab. Now the measurements are all, kind of eyeballing it. So you'll have to kind of use your experience to measure these out. In our first reaction, we're trying to decompose hydrogen peroxide. There's a couple different ways of doing that. We're using 6% hydrogen peroxide. I'm going to use around a couple milliliters. Like that. Now, we do have to use a Bunsen burner for this one, only to light our splint. We're using splint tests again. And we will be using a glowing splint test for this one, which will require me to just get the end of it nice and glowing with embers. This is a catalyst, manganese dioxide. It's a gray metallic looking catalyst. It's a powder. So what I'm going to do is add a pinch of this in there. And it's fizzing. So we want to test this with the glowing splint test. We'll get a nice glowing ember on the end and see if we can get it to relight. And we can. Can we do that again? Yep. Can we do it a third time? Take a closer look at that. Absolutely. Fourth time? Yep. I used most of it up. Let's see. Oh, still got it right about there. Boy, that might have been more than 6%, huh? Oh, that's still burning. Yep. All right, we'll set that off to the side. Put the splint in the solid waste container. So there's definitely a product out of that reaction. All right, moving on to reaction 2. We're going to do a very similar reaction. We'll be using aluminum oxide. So aluminum oxide is a solid. Looks like a lot of ionic compounds. They don't really have that much color variance. You can see it in the test tube. And according to the procedure, we're going to use the same setup but at a slight angle. And we're going to try to lower our glowing splint into there. This one, however, will be heated directly though. So put it at a slight angle, collect some gases from this. And we'll get our splint ready. Hey. Filming some decomposition reactions. We're on the aluminum oxide right now. So kind of hard to see from that distance, but in the test tube we have the aluminum oxide. It's still white in color. And with the introduction of the splint, we get no spark up. All right, so it's still glowing, but we don't have any relighting like we saw in the hydrogen peroxide, which is still going in the distance over there. All right, so observations for reaction 2. That's our aluminum oxide, and trying to decompose it using heat. So that's thermal decomposition. With the hydrogen peroxide, it was decomposition through use of a catalyst. But you can also thermally decompose hydrogen peroxide is another way of doing it. So now we're going to try to do the same kind of process, except with the calcium hydroxide. If you look at procedure 3, another test tube. Okay, calcium hydroxide. Another white powdery looking substance. Use about the same amount we did with the aluminum oxide down the bottom of our test tube. All right, for this one, we're going to be doing a different test, but the process is fairly similar. I'm going to mount this more horizontally and hopefully get it to create a vapor. We'll see if we can get that to happen. You know what I forgot? I forgot the cobalt chloride test strips. I know I forgot something. All right, so we need to use cobalt chloride test strips for this. And we can see hopefully that we do have some condensation happening in there. Now, you're not really supposed to handle these with your hands, but since I'm wearing a glove, it shouldn't be affected by my hand. But I'm just gonna rub that on the inside where I have the condensation from that. And what we see where I can get it to touch on the edges, we do have a color change. It's changing pink and white just on the edges where it touched the condensation. There you can see, hopefully. So we do have, put that in the solid waste, we do have a chemical change happening there with that one as well. All right, and lastly, we have the most difficult one to do. The copper 2 carbonate. So new test tube for that one. This aside. Copper 2 carbonate. This one we have to use a gas delivery tube setup, which is always fun. Typically, we would have warned you previously about this because it does pose a risk of explosion. So this is the gas delivery tube setup. I'm going to mount this before we get it going. And we'll get the water in a beaker. We've used this test before in a previous lab. And we're going to use it in a similar way this time. Yeah. All right. Okay, so we're heating the material. You can see right away we have bubbles happening down on this side. That's not a product from the reaction yet. That's just expansion of gases, which is why this poses a risk, because if you take the heat off and you don't take the hose out, then you'll suck the liquid in there. So we'll let that run for a bit. got some weird condensation happening there actually. Hopefully you can see the color change. It was a nice green color. It was one of the ones that actually had a nice color to it. Oh yeah, that's good. So what are you supposed to do first? Remember?
Yeah, you gotta take the turn the gas off.
There
And
gas
then
turned off.
take the
Get the hose out of there. Still a little bit of vapor coming out. Not really sure what that is. Might have been a little wet in there before. But we do have definitely a change in our lime water. And if you look at the material that we used, I keep misplacing my hot hand. Definitely quite a lot different as far as color. So those are the decomposition reactions. Remember again to make observations and reaction predictions as far as what you think happened in those. And yeah, we'll catch up with you with the single replacement reactions.